Hey guys, welcome to the long-awaited soldering tutorial. In this video, we're going to get into the nitty-gritties of how exactly to solder and build a VESC so that you can follow my previous 3 videos of VESCing 2 XRs and 1 GT as a blueprint to build your board. In front of me, this is all the essential tools that you will need to build a VESC. First of all, let's start with the soldering iron. The iron that I'm going to be demonstrating this soldering tutorial with is going to be the Pine-Sol soldering iron. This is a great first iron, I think, because I think it's very user-friendly and inviting to use. It can be powered by USB-C, which means you can power this with a power bank. So if you plan on going to a lot of one-wheel events, you could bring this and fix your board on the spot, even with no outlet. So by the time you graduate to a more expensive iron, this one is still great to keep around. Of course, you don't really have to get the Pine-Sol if it's too expensive for you. I will leave a link below to a more affordable option, although I haven't personally tried it. It looks pretty good. And one more that's highly recommended to me if you just want to go straight to the end game soldering iron. But no matter which one you choose, make sure you find one with a replaceable tip. Make sure that you can change the temperature on the iron, and make sure that it has some kind of like either auto shut off or a sleep mode, so that if you forgot to turn this off, it won't just burn through your tip throughout the night. The Pine-Sol came with this tip. This is like a pointy tip. So this is great for your balance leads. If you're fixing something on the PCB, you need something that's really fine tip. But for most of your build, I really prefer this end, which has got a flat side. This is great for your XT30s, which is gonna make up the majority of your solder job. And then for your discharge wires and your phase wires, where you need just a ton of heat output, I prefer this one, which has also got a flat side, and it's got a really big contact patch for your thicker gauge cables. So you can get the whole kit as I did here. Most of these are not necessary, and I barely use the rest of them other than these 3 I think should definitely get. With that, let's look at some other soldering accessories. I prefer a really solid soldering stand where if you put the iron in, there's nothing exposed on this end. It's not like a wire rack where you can actually touch it or something. I have really cluttered desk, and I am guilty of not cleaning my desk as often. So this soldering stand, if I just leave it there, I'm sure that nothing will burn on the other end. You'll need some brass wool and some, I just use kitchen sponge to clean the tips of your soldering iron. You will need flux and solder. So these two, the vocabulary here starts to get a little bit confusing. This is solder, but solder is made out of tin and lead. So if you hear someone say tin, lead, or solder, these all mean the same thing. And then flux is used to help the solder flow, but flux is made out of rosin. So if you hear someone say flux or rosin, those mean the same thing too. Helping hands, pretty much all of them suck. And I think this one sucks the least because it holds your stuff without like springing it back. So if you place something there, it like actually stays there. And I also put some heat shrink here to make sure it doesn't completely destroy whatever it's holding. And another type of helping hands that I find really helpful is a vice grip. I don't have a vice grip, so I just kind of made my own here. These are really handy in a one-wheel shop. You can use them to break the bead on a tire change by just cranking this down. You can use it to seat an MTE hub if it's not going in. And you can use them when I'm soldering to hold a clamp. So if you have some kind of clamp that can hold whatever you're soldering, you can clamp it onto your desk, and then that's not gonna move. Next up, if you're soldering and you make a mistake, you might want a solder stucker. This is a great fidget toy for you to play around with, but more than that, it acts as an eraser to fix your mistakes. This one is a metal build, so it will last a little longer, but it's also like $18. A cheap plastic solder sucker, this will do just fine. It might break like a few years earlier, but I've actually found this to even suck harder than this. So a cheap one like this will do just fine. For cables, you'll pretty much only need 3 types of cables. So these are your 18 gauge cables. These are great for your charge path. Those are used for everything between your charge port to the BMS and to the battery pack. And then for your discharge, you'll want to use 12 gauge. So that's everything from your battery to the controller and then to your motor through your phase wires. For all your data cables, you want to look at the JST connectors. So everything from the controller to the hall sensor to the foot pad, your CAN bus, your Bluetooth module, those all use the same kind of connector. Make sure you figure out which type of JST connector your controller uses. In my case, my boards are U-Box 80s, which uses the JST GH1.25. And these connectors all come in kits that includes all the connectors here. as well as the cables you'll need to connect these connectors. And then for the cables, make sure you find the ones with pre-crimped cables. That's this metal end here. Those are like little plugs that plug into the connectors here. So make sure you find a kit with pre-crimped cables so that you don't have to crimp your own cables, because that's very annoying. Now let's move on to the XT connectors. These will be used on everything to connect your 18 gauge cables to your 12 gauge cables. The way that these connectors are named, the number here, that designates the maximum continuous amperage that these connectors can handle. You'll definitely be needing the XT30 connectors. These, as the name suggests, these are rated for up to 30 amps continuous. Your typical hypercharger delivers around 6 amps continuous, so this connector will be plenty to handle everything in your charge path. Optionally, if you just want to keep one type of connector around, these will also be great to connect to your headlight modules. The XC60 and 90, these will be used for your discharge path, and you can pick either or. The XC60, these obviously are rated for up to 60 amps continuous. This will be just enough for everything but the P45 build. For P45, I think you need up to 90 amps continuous, but for your meat packs, your stock XR builds, your stock GT builds, these will be just enough. People choose this because it's very small, and so you can fit more into your builds. Now, I love the XC90s. If you are going to get the XC90s, I highly recommend you get the anti-spark version. The anti-spark is designated by this green band here, in contrast to this connector, which is not anti-spark. It doesn't have that green band. The reason I love anti-spark is that I am terrified of electronics, and the anti-spark feature here is designed to avoid the spark that happens when you plug connectors together. So that happens because your one end of your connector is usually connected to your battery pack with like 70 volts. The other end is on your controller, which not connected to power has 0 volts. The moment they touch, the voltage here is going to flow through, and that difference is so huge that it will create a giant spark. I'm really scared of that, so I use the anti-spark connector, which eliminates that kind of spark by putting a resistor on the end of the connector. So make sure that if you are going to get the XC90, spend the extra money to get the anti-spark version and skip the regular XC90. Otherwise, just use the XC60. Another really important consumable you'll need to work with these connectors are heat shrinks. These are 3-to-1 heat shrinks, so that means the diameter here will shrink by 3 times after it's heated. So these are used to insulate your connectors after you're done soldering. These also comes in kits, and I have more heat shrinks here than what is shown. Buy a kit of different diameters and you should be good. And if you're going to get heat shrinks, make sure you also get a heat gun. Your girlfriend's hairdryer won't get hot enough to shrink these heat shrinks. Additionally, you can also use this to melt hot glue, and obviously change grip tapes, which I am guilty of not doing often enough. Another type of insulator are electrical tapes. When working with electronics, insulators are always welcome. You can wrap potential points where things might fail and short. So electrical tape is great. This is Tessa tape, which is like a fabric type of tape. This is also great. Fish paper, this is great if you build batteries, and also Kapton tape, which I don't have. Never a bad idea to have a few of these. And then for working with wires, you'll need a wire peeler. This peels the end of your wires so that you can solder. And then you'll also need side cutters, which cuts stuff. I view these as consumable products because eventually the tips here is gonna dull. Just get whichever one is cheapest. You can buy these for like $9 for a pack of 5. And I also have a multi-tool around, although this is also not necessary. I've been getting a lot of questions on this hot glue gun. Also, I built this holster, which slides in like that, which I think is pretty cool. This hot glue gun is made by Hoto. They actually have a new version of this, which looks pretty cool. It electronically dispenses hot glue, so it's not a giant mess like the squeezing version. I love these because those are powered by batteries, so it's got a battery inside that you can run this without any wires, just like this. Their tools are slightly more expensive than average, but they make tools that I love using. And it's also got auto shut off, so when I'm done, I just leave it there and then it'll turn off by itself. Next up, you'll need a multimeter. After you're done soldering, you'll need a multimeter to check your work. Pretty much all of them will do, although the more expensive ones are easier to use. This one is not crazy expensive, and it's also made by a very reputable company, Fluke, which is known for their multimeters. The nicer ones will only have a few options here, so you're not burdened with choices. The cheaper ones, for every one of these settings, that has like different ranges, and you gotta select the right range for the stuff you're measuring. The more expensive ones, though, it will do auto ranging for you, so you only have a few choices. This one in particular, it can measure everything but amperage, which realistically, you're probably not going to be measuring. Last but not least, hands down, the most important tool that you will need is a fire extinguisher. I'm not kidding. If you're building a Onewheel, you will absolutely 100% need a fire extinguisher. These things are like 30 bucks. It can save your life. It can save your house from burning down. And after you get it, don't just hide it in your closet. Put it somewhere where it's easy to grab so that when things do go wrong, you're not digging through boxes to find your fire extinguisher. I put mine just on the desk right next to where I build. Very important that you get a fire extinguisher. So if this is the first time you're VESCing a board and you don't own any tools, for the same price that what Future Motion will charge you for a controller will hub swap, you can buy all the parts to fix it yourself and buy the tools to install the parts. And the next time your board is broken, you can pretty much fix it for free. Before you solder anything, make sure that whatever you're soldering is not directly connected to power. So disconnect the battery. That way, if you screw up, things won't blow up. Also, make sure to open your windows because the fumes can be pretty bad for you. So the most common type of soldering you'll do when building a Onewheel is soldering wires to XT connectors. These connectors, they look pretty much the same and they all pretty much solder the same way. But the bigger the connector, the more difficult it is to make a good solder joint. And obviously, the more crucial it is to make a good solder joint. I'm going to be demonstrating first with the easiest, which is the XT30, and then we're going to work our way up to the XT90. This applies to all XT connectors. All XT connectors, there are 2 pins inside, and then there's a flat side and a beveled side. Make sure when you're soldering, the flat side, in most cases, goes to positive. If you can help it, this side goes to positive, and the rounded, the beveled side, this side goes to negative. So that way, when you are plugging in the other end of your connector, it only goes in one way. Because this is beveled, if you plug it in the wrong way, it can't go in. The only gotcha here is you're working with a Future Motion hardware. So this is a stock XR pack. This doesn't apply to all Future Motion parts, but you gotta check if your stuff is reverse polarity. I think on all Future Motion hardware, black is still negative and red is still positive. They weren't crazy enough to swap the color wires. They're just really stupid about this XT connector. But you can see how the flat side of the XT60 here is wired to the negative, and the rounded side is wired to the positive, which obviously is wrong. And if you plug in a regular polarity XT60 on the other end, it's gonna short. So the way I like to work with this is I like to get out of the reverse polarity standard as soon as possible. I don't want to touch anything on the battery pack, but if I'm building something that connects to this, I convert it back to regular polarity on the next connector. Another good practice is you always want the female end to be whichever side is closest to the battery. It doesn't really matter when it's like all connected together and your board is running, but when you're working with your board with them pulled apart and those connectors are just like sitting there on the board, it's much easier to short the male end than it is to short the female end. And that's pretty obvious if you look inside the male end. Those are just like exposed pins, and if anything conductive were to fall in here, that's gonna short. But it's much harder to short the female end because it has to like go up, across, and down. So for example, if you're wiring this to your controller, the female end goes to the battery and the male end goes into your controller. Or if it's a headlight module, then your female end goes into your controller where power is applied, and the male end here goes into your headlight. Or if it's a charge port, when you're working with your board, obviously nothing is plugged into your charge port. So the power is still on the battery side, so this side goes into the battery, and this side goes into the charge port. If you're following my previous build guides and I'm not doing this, that's because I didn't know better. Now that you know, you should definitely do this. We're gonna work our way from the easiest, which is the XT30, all the way up to the XT90. Let's say we wanna solder some wires to this male end of the XT30. First thing to do, you flip it around and you check that these notches are aligned correctly. In this case, this one isn't aligned correctly, so we're gonna turn it until it's correct. The plastic used on the XT connectors, they are like high temperature plastic, but they still will get soft. And when they get soft, the pins here will start to move, and then you can't get a good connection later. To avoid this, you always want to solder with the other end joined together. And the other end will help keep the pins aligned, even if the plastic were to get soft. Now we can go ahead and place it on our makeshift vise. I have really shaky hands. If your hands are like super solid, you don't really have to mess with this. Sweet. And then let's get our soldering iron out. I'm going to be powering this with a MacBook charger, just with USB-C power delivery. This iron heats up pretty quickly. You can see on the temperature here, it's already at pretty high temps. Generally speaking, you always want to use the biggest tip you can to get the job done. If your soldering iron is dirty, you always want to clean it up. So put a little bit of water on here, and then you could go ahead and wipe this off really quickly. If it's really dirty, you can use something like a steel wool here and then just start stabbing it until your tip looks shiny again. By the way, it goes without saying, don't touch this part, it's really hot. Now let's go ahead and prep our wires. You're probably going to be soldering XC30s with these 18 gauge cables. So let's grab our side cutters and go ahead and cut it. And then we're gonna take our wire peeler here, peel the ends here. There we go. Before we solder this, we're gonna dip this tip in flux because that'll help the solder flow better. I went ahead and wrapped the other end here just to demonstrate how you can solder with the other end already attached to something. Make sure that before you start soldering, you put the heat shrink on. I cannot tell you how many times I've forgotten to do this. I have to desolder this, put the heat shrink on, and then resolder back in. I'm cheap, so I'm actually gonna cut this in half so I get double the heat shrink of what I paid for. Make sure that you don't just do it on this wire alone. Make sure you do it on both wires because I guarantee you will forget to put the second heat shrink on after you're done soldering the first wire. Put them on all of your wires at the same time and then start soldering. It's really hard to mess up soldering an XT30, so I'm gonna show you like the quick and easy way just so you can get started. So you wanna put this in here and then you're gonna stick it all the way down the hole so that it seats into the hole. This part I think is really unintuitive for beginners. We actually want the solder joint here to get hot enough to melt the solder. We don't actually want the soldering iron to be melting the solder because if the joint isn't hot enough to melt, that means the solder won't stick to the joint. So I'm gonna demonstrate the wrong way to do this. So if you just put the soldering iron on here and then start applying your tin, you realize it won't melt. And then when it did melt, you're gonna be really struggling to keep this tin on here. And when you go ahead and lift the soldering iron, this is actually a perfect example of a cold solder joint. You can see the solder formed this little blob here, and it didn't actually stick to whatever it's soldering. You can see it didn't really conform to the shape. It's just like a little bit of sticky tag. Even if you can't really pull this apart now, over time this is for sure going to fail. So the reason this happens is the joint didn't get hot enough to melt the solder. To get the joint hot, we actually want to apply a little bit of solder on the soldering iron first. And I know this just contradicted everything I said before, but we do this for the same reason that we put oil on our pan before we start frying things. It's the same reason we put thermal paste on our CPU before we put the heatsink on. The little bit of liquid here will really help increase the surface area between the soldering iron and our solder joint. Additionally, we're also going to adjust the temperature on our soldering iron, and this is why it's important to get a soldering iron with this feature. For XT30s, I think it's pretty easy to start melting things, so I'm not gonna go like all the way up top. I think somewhere around like 380 degrees will be totally fine. And this soldering iron actually have a boost mode, so when I'm soldering, if I find it's not hot enough, I can just temporarily boost it all the way up. So this time let's pre-tin, and then we're gonna put it on our joint. And then let the whole thing heat up first. So we're gonna wait a little bit until we see the solder starts to flow. And then we're gonna start applying a little bit of solder here. After we lift the soldering iron, it was shiny all the way through. That means the whole thing melted. It starts to cool off and it formed this shiny material here. A solder joint like this is how you know you did a decent job. You can see it did coat all the way across. The finish here is shiny. That means the whole thing melted. And most importantly, the shape of the solder here, it did conform to the shape of the solder joint. So that's how you know your solder joint is decent. Now if you look closely, this solder joint here isn't perfect. On the opposite side, you can see the solder didn't actually flow into the other end of this wire. Although this will work on the XT30, if you do the same approach on the XT60 or XT90, it can get pretty sketchy pretty fast. So let me go ahead and demonstrate the correct way to solder this so that the solder flows everywhere. First of all, again, we're gonna pre-tin our soldering iron. We're gonna also pre-tin the connector, and we're gonna pre-tin the wire too. Now with the solder already applied to both joints, so we're going to, again, put a little bit of solder on our soldering iron, and then we're gonna do the next step very quickly, like this. Now you can actually see some black spots on this solder joint, and that's probably because the soldering iron was hotter than it should be. But it definitely is not a cold solder joint, and if you flip to the other side, because we pre-tinned everything, the solder did flow on the other side too. This method, I think, is more sturdy than the easy method. Realistically, I think both of these will be fine. They will both hold up to reasonable abuse. And then you're gonna grab your heat gun, and then just start heating this until it seats. I always like to leave the heat gun on for like 3 seconds or 5 seconds longer than I think it should, because sometimes the heat shrink here didn't actually shrink all the way and it will actually come loose. If you don't have a heat gun for this step, I think a lighter can also work. Now that this is solid, we can go ahead and pull the other end apart, and then there is our XC connector soldered. And if you can get to this point, go ahead and pat yourself on the back because this is a huge achievement. Now let's move on to the XC60. We're gonna do these the same way. Flip it around, check that these pins are aligned correctly. If not, align them. The XC60 here, these are typically used on your discharge cables. Those are 12 gauge cables like this. Thicker gauge cables and bigger connectors like these will be much more difficult to solder than your XC30s. Instead of using heat shrinks like the XC30s, we're gonna be using this little cover to finish the job. So we're gonna put the cover on our connector first. Actually, it might be easier to do this before you peel. Now we're gonna put on a little bit of rosin. And I know this is disgusting, but go ahead and rub the rosin in. The rosin here, this will help the solder flow, and that'll help us get a better connection. After that, wipe your hands down. We're gonna grab this big soldering iron tip, and then make sure it's on a high temperature. This soldering iron isn't crazy powerful, but we're gonna have it on the highest temperature just to output the most we can. If you have a more powerful soldering iron, it will really help make this process easier, but I'm gonna demonstrate that this is perfectly doable with just a pine sol. Soldering XC60, this is gonna be pretty much the same as the XC30, just gonna be more heat and more solder. So first we're going to pre-tin everything. For pre-tinning, you want to fill up the solder kind of halfway, so starting from the bottom here all the way sloped to the top. And if you have a whole bunch of stuff to pre-tin, a trick here is you can grab your solder and then go ahead and prop this on your desk facing upwards. And now you can hold your wire and your soldering iron and get pre-tinning. Double check your polarity, make sure flat side is going to positive. Pre-tin your soldering iron and just press this in. Now we can do the other side, same process. Sweet, that looks like a pretty solid joint. Now because we used the pre-tin approach, we can see that the solder did go all the way around the solder joint. We can't really see it inside, but I bet that the solder also did flow into the connector. Now we can put the sleeve on, and notice how the XC60 sleeve actually goes over the connector. This is in contrast to the XC90 sleeve, which actually seats inside the connector. So you can see that this sleeve actually comes in pretty close contact with the metal here, which will create some problems when you're soldering, because if your solder starts to overflow and starts filling up these channels, this sleeve here wouldn't sit after you're done soldering. The easiest way to make this mistake is if you're soldering upright like this. Now if we're trying to slide this cover back on, it won't sit. To avoid filling up the slot, we want to make sure that we're always soldering XC90s or any XC connector in that matter on the side. That way when solder melts and flows, it will flow downward, it won't flow into the slots. Now that we're working with even bigger solder joints, I usually don't like to just hold the spool like this and then start extruding, because by the time you run out of solder, you will then have to on the fly try to detangle this mess and try to unroll, which is not something easy to do. So the way I like to work is I like to take a whole bunch of excess and then just leave the spool on the desk, and then I have all this excess. I'm gonna hold a little bit, and then by the time I run out, it's very easy to just back off to apply for more. So we're gonna do the same thing as the XC60. We're gonna pre-tin both the connectors and the wires. And you can see how much solder we're using. There, those are pretty solid joints. Because we soldered them on the side, we don't get any excess solder flowing into the slot, which means this little clip here will push in very nicely. Perfect. Next, let's talk about how to solder thin cables to thin cables. This is a type of joint you use pretty often when you are, for example, cutting the ends of your motor wire and then having to solder that to another type of connector, or to do cable glands altogether. Or if you're working on XRs and you've got a bunch of these switchcraft connectors for your foot pad and your hall sensors, you need to connect these wires to these pins, which these pins are thin enough to basically treat them as another thin wire. These joints are pretty easy. You want to grab your wire peeler and then start peeling away the wire. In some cases, your thinnest setting on your peeler here won't be able to peel the cable. In that case, a trick is to tilt your wire peeler to the direction where the blade is and then peel. For thin cables, you want a nice and long connection just because there's so little material to work with. Now you can grab your other end, and this is a good time to start using your helping hands. And for soldering wires, it's always best to have some kind of mechanical stress between the two, so that even if the solder were to fail, which it shouldn't ever fail, the wires are binded together. This shouldn't really make a difference, but it's nice if you can do it. For your soldering iron, I'm using this thin tip, but realistically, I think any of them will do. Just make sure you don't completely burn through your cable. If you want, also dip them in flux first, but for something as thin as this, there should be no problem of the solder flowing, and I don't think it's really necessary. Now you can put the heat shrink back on and then shrink it. Only thing to watch out for these thin cables is you don't want the helping hands to damage the cables. You can see that it did kind of make an indent here. And when cables are heated, these silicone materials become kind of soft, and sometimes you can actually get a breach just because the clamps are so sharp. So you can put a little bit of heat shrink on there to help, or you can clamp them further away from your solder joint just so the heat doesn't climb as much. Next, let's talk about how to solder thick cables to thick cables. This is a joint you'll use when you're extending your motor phase wires. Stuff like this takes a really powerful soldering iron, so I'm going to be demonstrating two ways to do this. The first way is the correct way to solder this. We're going to dip it in flux first, and then we're going to shuffle them together like a deck of cards. This way, there is mechanical stress between the joints, and that's going to make for a more solid connection. For thick gauge cables, again, we want to use a big tip, and you want to be on super high temperature. Now we can just start laying down the solder. This will take up a lot of solder. If it bulges out too much, you can always use a side cutter to trim a little bit before you put the heat shrink back on. Not particularly proud of this joint, but it will do the trick. For soldering, you always want to go as high temperature as possible and as quickly as possible, especially on something like this, because the soldering iron was on there for like a good minute, and the heat was able to, I can feel the heat climb all the way throughout the cable. So after you're done soldering, you can just try bending it to see where in your cable the solder has climbed up to, and that'll give you a good idea of whether you should do the job faster or shorter. I feel like these joints I could always have gone a little bit faster. The other way to do this, which I haven't seen anyone do before other than Maeve, who showed me this trick I ended up really liking, is after you're done putting flux on these, you want to fan them out. The reason you fan this out is the same reason that a thin steak cooks faster. The thinner it is, the easier it is for heat to penetrate throughout. And then we can tin these. Now we can grab our side cutters and then cut these to diamond shapes. This side is a little rough, so I actually like to put them side to side instead of top down. This way the solder can flow into the crevice instead of on top of it. Now we can heat one side, and because this is really thin, if you have a low powered soldering iron, this might actually be the easiest way to do this. See how my soldering iron is on this side, and I'm touching it on the other end to make sure the solder melted all the way through. Now let's put our two joints side by side. The shuffling method is definitely the one that you'll be taught how to do, but I really like the diamond method. Theoretically, I think the shuffling method is stronger than the diamond method, but realistically, I think both are plenty strong enough for reasonable abuse. And the diamond method, because you can pre-tin, I think it's much more controllable that the solder was soaked all the way through, and because they're just put on top of each other, you can also desolder this joint way easier. Plus, I think it also looks cleaner. You can make your own decisions here about which one you prefer, but personally this one is my favorite. Last thing I want to show you guys before we wrap up the video is how to check your work with a multimeter. There's really only 3 features that you ever need on a multimeter when you're building a Onewheel, and those are going to help you troubleshoot and figure out what you are doing and what you're doing wrong. When you're shopping for multimeters, you might see meters like these with a few options, and multimeters like these with just a ton of different features. The reason there are so many options is actually because it's not intelligent. Let's say we're trying to measure a Onewheel battery, which should be around 50 to 80 volts. So on multimeters like these, you actually have to select the right range for the stuff you're measuring. If you were to range this on the 600 volt mark when you're measuring something 60 volts, you wouldn't get as good of an accuracy of the stuff you're measuring. Or if you put it on the 2 volt mark when you're measuring a 60 volts, then you wouldn't be able to measure 60 volts. So now you can see that these meters, they're actually more sophisticated, because if you're measuring DC voltage, then you just put it on the DC voltage and it'll do this ranging for you. So you don't need to go through the work of selecting like 5 different DC voltage ranges for the stuff you're measuring. It will do that ranging for you and get the best accuracy based on the things you're measuring. Speaking of DC voltage, the first thing you need to know how to measure is DC voltage, and also how to use the DC voltage to check polarity. As I said before, this stock XR pack is a reverse polarity battery pack, but if you didn't know the polarity of your battery pack, you can very easily check it with a multimeter. While you're measuring live voltage, remember that these tips are conductive and they will move around, so make sure that these tips do not short whatever you're measuring. I know that sounds obvious, but this is the first BMS that I blew when I just started doing DIY electronics. Like, I blew this on day 1 because I was trying to measure these connectors here. It didn't occur to me that these are live voltage, so when my hand shook, that blew the whole thing up. So make sure you do not repeat my mistake. When I'm measuring, I make sure to insert one probe at a time. So I would insert this one fully and then insert this one, and be very careful that these are not shorting. So now you can see a voltage being read here, and you can see this is measuring at 57.92 volts, but you will see that this is actually a negative number. When you're getting a negative number, that means these 2 probes need to be flipped. And you can see that this does make sense because the red probe is plugged into the black wire and the black probe is plugged into the red wire. So now let's plug them in according to their color and make sure to do them one at a time. Cool, now we're getting a positive reading on the multimeter. That means that these polarity are correct. So this is how we're able to verify that the cable color does correspond to their polarity. And then when you're taking them out, make sure you do them one at a time. Next thing you want to know how to measure is how to measure continuity. Continuity is denoted by a logo like this, which looks like a sound wave. On this particular multimeter, you put it on the ohm setting, which measures resistance first, and then the yellow here would correspond to the yellow button, so you press it until you see the correspondent logo pops up on the display, and that means it's measuring continuity. Continuity is one of the features you'll use most often. It tells you if your stuff is connected properly. When you touch these probes together, you can hear it beep. You can use this to check if your stuff is conductive. For example, now we know this is conductive. This plastic is not conductive. This metal lid is not conductive. And this charge port ring is conductive. But more importantly, we can also use it to check that our wiring is correct. I particularly want to check if this charge port is wired correctly to this XC30 that goes into the battery. There's some pretty complicated wiring happening in here. So this charge port first goes into the diode and then goes into the harness and all the way here. So instead of verifying each one individually, we can just check continuity between the wires. So first let's check negative. Doesn't matter which pin you put where, but make sure that this is touching the pin. And then we can use this probe to check that this pin is connected to the negative pin here. If we put our probe on the positive wire here and then try to probe around, you can see that we're not able to get a reading on the positive line. In this particular case, don't panic, because I know for a fact that I wired a diode on the positive line. To measure a diode, that brings us to the third feature, which is represented by this triangle with a line symbol. The way a diode works is it restricts electricity to only flow in one direction. And if you have a diode in here, that means you can restrict the electricity to only flow from negative to positive and not the other way around, which means you're only able to charge the board and not discharge by blowing up your charge ports. This is a diode. There's about 4 of these inside of the controller here. But just to demonstrate the point, I think it might be easier to see this by itself. If you try to measure this diode, you can see that we are able to get a measurement in this orientation. And that means the diode is allowing electricity to float from negative to positive in this direction. But if we flip the diode, you'll realize that we are not able to get a measurement anymore. And that means the diode is stopping the electricity from bridging this journey. To apply that on our charge port, we can first try to measure it just in whichever orientation we want. And you can see that we are able to get a measurement this time. And that means the diode is oriented correctly to make sure the electricity flows from the red probe to the black probe. And now if we swap it, we aren't able to get a measurement anymore. Keep in mind that I am measuring the positive line, and if you have your diode on the negative line, then the direction of the diode needs to be flipped. At this point, I will highly encourage you to practice on some spare wires before you start messing with your board, because I didn't, and I blew $300 of BMS just because I couldn't bother wasting $2 of wires. If you really can't bother having your solder joints go to waste, I would recommend you to start by practicing on soldering one of the charger adapters, because you're gonna be making these anyways. This is a small project that you can get your hands dirty with soldering. You can practice peeling wires, you can practice with XD connectors and checking polarity and heat shrinks on a small project that is disposable before you start messing with $100 hardwares. After you feel confident in your soldering skills, you can then proceed to my other step-by-step videos. I appreciate you guys for staying the whole way through. Seems like longer stuff is what you guys wanted. And for my next video, I'm doing a video on remote tilt. There's a lot more to these things than hill climbs. Most people think that if you don't climb hills, you don't need a remote. But actually, these things will completely change the way you ride anything. And there's a lot of cool hidden features on this remote that people are not talking about. So that's gonna be my next video. Make sure to subscribe to see that. Bye.